Now, let's delve into the details of IAM policies. First, we'll take a look at the user management section. You'll notice that our user, Danielle, belongs to the admin group and thus possesses full administrative access rights within AWS. This level of access means that when I log in using Danielle's account and navigate to the IAM Console, I can easily access the user list from the left sidebar. In this view, you can see my user, Danielle, prominently listed. Because she is an administrator, Danielle has the authority to perform any action within the system. However, for demonstration purposes, I will remove Danielle from the admin group. By doing so, the permissions associated with her account will be revoked. To confirm this change, let's refresh the page. Now, we see that there are 0 users displayed and an error message appears indicating access denied. The specific error states that I lack permission to execute the IAM list users operation. This illustrates that after removing Danielle from the admin group, her permissions to view users have been effectively disabled. Now, let's work on restoring those permissions. We will navigate back to the IAM section and find Danielle's account under the user listings. Currently, as you can observe, Danielle has no permission policies assigned to her. To rectify this, we need to add some permissions. We have 2 options. We could attach policies directly, or we could create an inline policy. But for simplicity's sake, let's proceed with adding permissions directly to her user account. The specific policy I plan to attach is IAM read-only access. This permission will enable Danielle to view IAM resources without granting her any modification rights, which is precisely what we need for our current needs. I will add this permission now. Excellent. The IAM read-only access policy has been successfully assigned. Let's refresh the page again to check the updates. Now, I can successfully perform API calls and access the Danielle user details once more. This means I can view the list of users, check which user groups, like the admin group, she is a part of. And now let's test if we can create a new group. I will go ahead and attempt to set up a new group called DevOps. Let's proceed with creating this group. As you can observe, I am unable to create a group due to my current access level. Specifically, I only have read-only permissions within the Identity and Access Management (IAM) system. This limitation clearly illustrates that permissions can be strictly tailored to what users are authorized to perform. If I intended to grant permissions to create groups, I would need to assign broader permission sets, such as the IAM Full Access policy, which grants comprehensive privileges. Now, let's proceed with some practical steps. I will navigate over to the User Groups section on the left-hand side of the interface, where I will initiate the creation of a new group. This group will be designated as DevOps. I will also include the user, Danielle, in this group. For the policy assignment, let's attach a policy we can find. Any basic one will suffice for this demonstration. After successfully creating this group, we will next access the admin group. Here, I will add users once again, re-adding Danielle into this admin group. To verify our changes, let's go back and examine Danielle's user profile. We will head over to IAM, proceed to the user section, and locate Danielle. Upon reviewing her permissions, we can see that Danielle has 3 policies linked to her account. First, there's the administrator access, which she inherits from the admin group. Secondly, there's a managed policy that comes from her connection to the DevOps group. Lastly, she possesses the IAM read-only access policy, which has been directly assigned to her profile. This overview demonstrates how permissions can be inherited in various ways based on their attachment points. Next, Let's delve deeper into policies for a clearer understanding. On the left side menu, we will find and select the Policies section. I'd like to focus on the Administrator Access policy to highlight its features. This policy grants full administrative access across all resources and services within AWS. A quick glance at the permissions defined in this policy reveals that it encompasses a wide range of AWS services. It's important to note that the number of services available can evolve over time, but rest assured the course content will remain current. In summary, this Administrator Access policy allows unrestricted access, tailoring the experiences of users based on the functionalities they require. So, how exactly is this permission structured? If you click on the JSON option, you'll see the JSON representation of this policy. Here, we can observe that it contains allow for both action and resource, indicated by the asterisks, star. In the context of AWS, a star signifies everything, which means this policy permits any action on any resource. Essentially, granting permission for all actions across all resources translates to providing full administrative access to an individual. This is important to understand as it defines the scope of access granted. Now, let's examine another policy, such as the IAM read-only access that we discussed earlier. Upon inspection, we note that IAM is authorized with full list and limited read capabilities. If we click on this policy, we can view the complete list of API calls that are permitted under this policy, which is quite useful for understanding its capabilities. To see the underlying structure of this policy, let's switch to the JSON view. The JSON document details the policy's definition, indicating that the effect is set to allow, followed by a list of API calls that are included in the authorization. For instance, we see an entry for GET, which signifies that any call beginning with GET, like GET users or GET groups, is permitted. Similarly, there's a list entry allowing operations such as list users or list groups. Utilizing an asterisk in this manner helps to group multiple API calls under a single authorization rule, making it efficient and comprehensive. All these allowed actions apply to resource, summarizing the elements of the read-only IAM access policy effectively. This clarity is very valuable when designing access controls. Furthermore, you have the option to create a custom policy tailored to your specific needs. AWS provides a visual editor as well as a JSON editor for this purpose. If you're comfortable with JSON, you can easily modify and craft your own JSON document using their intuitive builder, which simplifies the creation process significantly. Alternatively, the visual editor offers a more user-friendly interface. For instance, let's say you want to develop a policy for IAM actions. What specific actions do you wish to authorize? Perhaps you'd like to include list users as one of the actions. We would select list users and also get user, thus focusing on these two API calls specifically. As we go through the selections, you'll see that we've chosen one action from a total of 38 available in the list and one from the 32 options in the read category. The next step involves deciding on the scope of this authorization, whether it should apply to all resources or only to particular ones. This selection process helps ensure that your policies are correctly tailored and secure. In this segment, we'll explore a straightforward yet effective feature. As you can observe, this policy builder is quite user-friendly. When you click on the Next button, you'll be prompted to name your policy, which we're calling IAM Policy for demonstration purposes. After that, we proceed to create this policy. If we take a closer look at the policy we've just established, we can examine the underlying JSON. Here, it becomes evident that, via the visual editor, we've granted permissions for IAM, list users, and IAM, get user on resource. This flexibility allows us to easily tailor access controls. Subsequently, you can attach this policy either to specific user accounts or group configurations, enabling efficient management of permissions in AWS. Now, to conclude this practical demonstration, let's navigate to the User Group section, where I'll be removing the DevOps group since it's no longer required for our purposes. Next, I will access my user profile for Danielle and eliminate the IAM read-only access that was attached to her account directly. Now, Danielle is solely part of the admin group, providing her with full administrative privileges. To verify everything is functioning properly, I will return to the IAM Console and examine the list of users. As you can see, all details appear correct and everything is operating as expected. That wraps up this tutorial session. I hope you found it informative and engaging. Looking forward to seeing you in the next lecture.